Hello there. So for you guys studying product design at the University of Birmingham, essentially I've been asked by one of your lecturers, Gerard, to just speak about my experience and IDC as a company in terms of what we do and how we use computer-aided design packages and prototyping as part of our development process when we're developing products. So my name's Nick Chubb. I am the lead industrial designer at IDC. IDC are a full service product development agency. So we work on physical products. About 50 to 60% of that is medical devices and healthcare projects. The remainder is made up of sort of consumer products, electronics, and sort of specialist industrial equipment, and sometimes quite scientific laboratory equipment and things like that, but it's very, very varied. So our main CAD package that we use at IDC is SolidWorks, and this features heavily throughout our workflow. Just to give you an idea in terms of the type of design consultancy that we are, over 90% of what we work on actually goes into production, which is pretty high for an agency. So we employ sort of pure mechanical engineers, as well as sort of all-round product design engineers and industrial designers, but we also offer in-house electronics capability. So we have electronics engineers and also project managers in that mix as well. And so to give you an idea of a recent project, the latest one to launch was actually a virtual reality camera bar that's used by Hollywood production companies. So the previous model of the product was actually used in some Star Wars movies, and it's used by Marvel and things like that. So they had a very clear idea of what they wanted. Not all projects start out that way. So some projects require a bit more of a strategic and research piece at the beginning to actually uncover and identify what the requirements should be. In this particular project, it was quite refined already when the brief came to us. In terms of how CAD was used throughout that project, so we would have, there was an Intel product that the camera bar uses, and so we received the CAD file of this Intel component, and so we would have analysed the geometry of that within SolidWorks. A big part of the project was actually heat dissipation, so heat was a bit of an issue. So after we'd kind of figured out all the requirements of the product and figured out that this was one of the problems, when we'd gone down a particular design direction, we used CAD as a way to build prototypes through 3D printing, but also combining that with some metal parts as well, to then run tests to test the heat dissipation and the thermal performance. We'd then develop the whole design in SolidWorks to create prototypes to assess form, and then also as we moved later down in the development process, we'd actually be we sort of have our own internal workshop as well. So we'd be using our CNC machines in the workshop because the final thing was made out of machined aluminium. So the first prototypes were kind of just bits of foam, kind of rough and ready mock-ups. Then it became FDM 3D printed prototypes. And then later down the line, we're actually machining these models that weren't the final design, but it gave us a really great sense of what the final design would be like. And then eventually the end production units as well. So SolidWorks was CAD packaged throughout all of that, and you can see that there's different prototypes for different purposes. Some prototypes are purely for figuring out different usability issues. Some are for, like I said, for testing thermal performance and heat tests, and then others you just want to reflect on the form of the product and really see it in a physical sense and handle it and understand the proportions in the form in 3 dimensions. So different ones for different purposes there. I've got a prototype here from a different project. This was a wetsuit washer, and so you can see that this is a pretty large SLA print that we did. So again, this would have started out as sketch work that had then been generated, and different prototypes were built without any CAD, so kind of bending coat hangers and using different sort of tubes and plumbing parts to then pump water through it and see how it would spray out. So quite a lot of prototyping is done, you know, kind of quite rough and ready, and just using what's around you and using different parts. It's normally, it depends on the project, but sometimes it can be quite late before anything that's actually a prototype that's been derived from some actual CAD. But yeah, this one was, these are the A surfaces, and kind of getting quite close to the final design where a large SLA was made and then the piping put on the inside. Essentially for that one, you put a wetsuit over the top and it would spray water from the inside to clean the inside of the suit, and then had a shower head that would clean the outside as well. Again, that was all done in SolidWorks. Another project I've got here from a different side in terms of prototyping. This was for a medical company in China who, it was one product that could be used in a couple of different scenarios in terms of the markets that it went into, but one was for actually a handheld device that was an electronic muscle stimulator. And so it had this handheld device, and so some of the initial concepts were just using different sort of blue foam models to look at different handling and different setups. So you can see there's kind of various different interfaces on there, and there's no CAD involved with that. It's purely just sketch models, and that was kind of taken to another level in terms of using pink foam for some more refined models as opposed to just the blue foam. And then as that developed, you know, it gets developed in CAD, and illustrations and sketches get more refined to the point where you are then handling something that feels much closer to the final product. So depending on the need for the prototype, sometimes we'll use FDM printing and sometimes we'll use SLA. When it's earlier in the process, we'll use FDM printing if it's purely just for either form, where it might be an FDM, or we might just use foam. But it's not, basically it acts as a feedback loop, you know, so that's essentially what prototyping is. You're making a prototype in order to test some thinking, and then the lessons on the back of that prototype is going to inform the design development. And so we always want to be thinking about what's the most appropriate prototyping method for that. And so SLA is pretty expensive and takes quite a long time. So if that feels a little over refined for what we want to find out at a particular stage, then, you know, either just slapping parts together that are just lying around the workshop or doing a quick FDM print can normally be the better way to do that. This is actually, this was a body-worn sensor that could be used in hospitals. And so you can see this main device part snapped into another housing. And so getting that click right, you know, you can think about it theoretically in CAD, and it was developed in SolidWorks, but really you only get a great sense of how effective those snap fittings are when you then prototype it. And then this is essentially when it's come off the first molds that were created. So like I said, we get involved in the product development process, everything right from research to concept development and industrial design and mechanical engineering. SolidWorks is the main package we use. And one thing I would say on that is that these are just tools that help the designer. And one thing that students should be wary of is just going straight into CAD and end up designing in CAD. One thing that I kind of try to share with the team and promote is that we are just thinking about what the most appropriate tools are. Just because SolidWorks is there, or whatever CAD package you use, it doesn't mean that that should always be the thing that you jump into straight away. It's not a place for coming up with ideas. Sometimes it can actually limit your thinking, so I'd bear that in mind as well. And then the other thing about the prototyping, of thinking about the most appropriate prototyping method for what you're trying to achieve. So for instance, if you are developing a form, then you can kind of, if you were using blue foam and shaping that, there's kind of an instant feedback loop, because let's say it's in terms of usability or ergonomics, you're adjusting the design in real time as you handle it, and then you can get various different people to handle it and then instantly craft that as you go. Whereas to CAD something up, you have to know every single thing about the what you're creating right at the beginning, and then you have to wait for that to be printed before you can then just handle it, and you might just think, oh no, that's too small, in which case to go through that process again, the feedback loop is much longer than had you just worked in foam. So because 3D printing and CAD are incredibly powerful in the right setting, there is a danger that people use them when they're actually not the most appropriate. So that'd just be something else to think about. If any students want to submit some questions to Gerard or anyone else to send through to me to answer on the back of this, or drop it in the comments, then feel free to do so, and thank you very much.